For this question, we have an element with sigma x equal to 100 megapascals, sigma y equal to minus 50 megapascals, and the rest of the stresses set to 0. And we are to find the absolute maximum shear stress. So we're fortunate in this problem in that we have a state of principal stress given to us. There are no shear stresses, and sigma x is a normal stress, sigma y is a normal stress, of course the normal stresses, and sigma z is equal to 0 megapascals. So let's go ahead and draw the appropriate Mohr circles and then figure out what the radius of the largest Mohr circle would be to find the absolute maximum shear stress. So for this problem, what we'll do is start off by drawing Mohr's circles on a sigma tau coordinate system as we've drawn here. And we see that we have one point out at 100 megapascals, and that is the sigma x. And we have another location here that's about half, so we'll do it out here. This is going to be minus 50 megapascals. And we have also the fact that sigma z is equal to 0. And so where does sigma z go? Well, we're going to put it right here on the origin. So in reality, we were given a state of principal stress where sigma 1 is 100 megapascals. Oops. Like that. Sigma 2 is equal to minus 50 megapascals, and sigma 3 is equal to 0. So we very roughly draw the Mohr circles, and you can see this is kind of rough, and this would correspond to the Mohr circle for the xz plane. This one over here will correspond to the Mohr circle for the YZ plane. And then we'll have the Mohr circle that corresponds to the XY plane, like this. Okay, so we have three more circles. And the question is, which one of these circles has the largest radius? Because that radius will give us the maximum shear stress. So we can see here that this circle is going to give us the tau max. And this is really the absolute max. Sometimes I do tau sub absolute max. So we can write it out like that, sure. So this is going to give us the absolute max. Now, how do we figure out what that radius is? Well, we look, what is the diameter? Well, the diameter, right, the diameter, or 2 times tau absolute max, is equal to the 100 megapascals that we have here minus the minus 50 megapascals that we have here, right? That's going to give us the diameter of this circle, that large one. So we can say that's going to be 100 megapascals minus negative 50 megapascals, and that means that the absolute max would be equal to 150 megapascals divided by 2, or 75 megapascals. Once again, this fast technique for finding the maximum shear stress. First, in the past, we were looking at maximum shear stress in just a plane, but it also applies, of course, to finding the absolute maximum shear stress for a given state of stress in a material element. And if you're given the principal stresses, it's very fast. So instead of using some of the equations or the trial and error methods that we've described previously, this technique is much faster, and I think it's pretty intuitive, and it's nice because it uses a graphical method. Anyway, I hope you have found this video helpful. Thank you.